Hello and welcome back. So in the last video, we were kind of talking about how we can cheese the same conclusion that a paired t-test gives with a one sample t-test, okay? Both of these things are essentially doing the same thing, so long as we specify the fact that the data are paired, or if we calculate our own paired difference column. Now, what happens if you accidentally do the wrong test? Okay, what if we were to use a two sample slash, we'll just call it, well, not just, but oh my gosh, independent t-test. Okay, we'll say on paired data. Okay, this is wrong. You should not do this. And I know, oh my gosh, I know you would never do this. Of course not. Of course not. But there are some morons out there that will do this without even thinking, okay? Now, we know our data are paired. We know that these columns represent the same person just over some period of time, okay? And we have this kind of ID column here denoting that, okay? But if you are somebody, well, not you, of course, but you know, the royal you, that didn't know that, okay? That you thought that this was one group of people without booze, you tested their reaction time, and then got a different group of people and gave them a bunch of booze and then tested their reaction time. That means that these two things would be independent, okay? They are not in this case. I just want to drive that home. These are paired data, okay? And you can only do what we did here, this difference, this paired difference column. You can only do that with paired data, okay? But let's say you didn't know that, okay? And let's say that you said, okay, I know that these are two columns of data. That means I have two samples. So I'm just going to go ahead and run a t-test on it without even thinking of anything else, okay? So we grab our reaction and then we specify post first because there's still a little bit of subtraction in there. We want to make sure we have, have all positive values for differences. And I run this. Okay, let's just take a look down here and see how this is different. This is wrong. Okay, we have paired data. That means we have to use a paired t-test, but we didn't. Okay, we made a mistake, and mistakes are fine. You know, as long as you reconcile mistakes, then you know you're good. But let's take a look at this. So we have our t-stat and our degrees of freedom, whatever. Let's look at the p-value. Now, let's kind of go back in time and remember what exactly we're doing here, okay? What exactly we're doing. Our alternative hypothesis, very gracefully written here, is that the true difference in means is not equal to 0, okay? And we only claim that when our p-value is less than 0.05. Is our p-value less than 0.05 here? No, it's not, okay? So by doing this independent sample t-test, we have a different conclusion. We have a different conclusion than the paired t-test gave us, right? We don't have essentially the right answer here, okay? And we know that because our p-value is greater than 0.05. So in this case, based on this p-value, we say that there is no difference between the pre and post reaction time after drinking. Now, sometimes, who cares, right? There are some times where you don't really necessarily care about the implications of your conclusions, right? In this case, we did the wrong test. And now we are saying that essentially it is okay if pilots drink, when we know for a fact that based on the paired t-test, accounting for the fact that the data are paired, okay, for this kind of thing, right, for this behavior, we know that the claim that we just made is not true. We know that it does affect your reaction time. And if you're just kind of, again, not you, but royal you, second person you, if you're doing, you know, being kind of careless and just doing this, then you're going to say, yeah, it's totally fine for pilots to drink and fly, right? Because my p-value is over 0.05. Barely, it is barely over, but it's still, you know, conventionally, we say that there is no difference between the pre and the post, that there is no effect of alcohol on reaction time. Now, that's going to raise the eyebrows of a lot of people. But when you say, I did the correct tests and I did statistics and blah, 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 then people say, okay, I trust you. You know, that goes against my intuition, but whatever. That's not good. Sometimes the conclusions really do have some ramifications, right? In this case, it would. You got to have a bunch of drunk pilots crashing planes, okay? not to make, you know, any jokes about that, but of course, very serious. But still, we made the wrong conclusion here, okay? We made something that is not encapsulating the truth. We did legitimate statistics and we did legitimate math, okay? Or at least the computer did. But we did not tell the computer the right thing to do, okay? We got to think. As statisticians, man, we have got to think about what we're doing here and the ramifications. We want to really make sure we're doing the correct thing, okay? Let's also take a look at kind of the rest here too, because this is important. So notice the 95% confidence interval. It ranges from a negative value to a positive value. When we're testing differences in means, okay, notice that 0 is contained in this interval, okay? So without even looking at the p-value, we'll just ignore this for now. If we're saying there's a 95% chance that the true mean is contained within this, the true difference in means is contained within this interval, there's a 95% chance that that difference in means is 0, right? And so who cares if the difference is 0? Who cares if it's negative? Who cares if it's positive? This is telling us that we just don't really know where, you know, the effect essentially of the intervention of the thing, and booze in this case, right? We don't know. We just have no idea. So just based on the 95% confidence interval, the fact that it contains 0 means that we're done. We've got nothing, okay? The test, the conclusion is that, you know, there is no effect, right? It's going to be negative, it's going to be 0, it's going to be positive, it's going to be all over the place. We're just not sure, okay? We do know, I mean, this is still calculated legitimately, okay? And the conclusion still also is that there's a 95% chance that based on this test and based on the sample, that the true population difference is contained in this interval. That is still true. But the fact that it contains 0 means that we don't give a rip, okay? So, and that's also reflected in the p-value here. If the p-value is over 0.05, then the confidence interval is going to contain 0. If the interval contains 0, then the p-value is going to be over our alpha. It's going to be greater than our alpha, okay? Again, this is not the right test to do. This is totally wrong. This is going to result in a lot of catastrophe, and it's just no good, okay? So this is why you always want to make sure you do the right test. If you have paired data, you do a paired t-test, or you do a one sample t-test on the difference. You have to create that difference column yourself, okay? Independent samples t-tests are used for 2 independent samples, okay? I get on a soapbox here because what we did here is legit, right? The computer is doing real math and we're doing real stats. However, the conclusion we made is false, okay? The conclusion we made is misleading, okay? The test is legit, but we know as statisticians that is, you know, wrong, okay? So with that, I've got one more little thing to talk about and we will go from there. All right.